Hey everyone. The last lesson for exponents and logarithms, and probably the best lesson because we are going to tie so many skills together in our last, 3, 4 examples that we're going to work through here today. We're going to take skills from from Math 30-1. How do you change things from a log equation to exponential log? We're going to use some of the rules of logarithms. So it's just a great way to wrap things up. So anyways, question number one, or skill number one, I guess, is what happens when your base for your exponential function is not base e? Well, we know that base e to the x, it's the special, right? Either's number allows you to take the slope, and the slope is the same as the y value in the function. But what happens when your base is not e? So to find this answer, we're going to actually put base e back in the question. To put base e back in the question, you take the natural log. So you natural log of y, and then you think about the power rule. Whatever the exponent is goes in front, and then you have natural log of 2. And then we're going to take this derivative, right? So we take this derivative of the log expression, the same thing as taking the derivative of the original function. One of the things that people get stuck on, though, is still you get this natural log of 2. We forget the natural log of 2 is actually just a constant term. The same way, if you have y equals 2x cubed, y prime is 2 times 3x squared. When it's a constant, it doesn't have any impact in your first step of taking a derivative. So we know, going back to our question then, natural log of y, if you take the derivative of a log of function, it's 1 over the function. It's the reciprocal of the function. And then you take the derivative of whatever you have here. So it's 1 over y dy dx. And we know that the derivative of x is just 1, and natural log of 2 stays because it's the constant. The same way the 2 stayed, it's a constant. So then how do you solve for dy dx? Well, this 1 over y, if you cross multiply, this becomes 1 times y, which is just y. We started off with y equaling 2 to the x, so I replace this y with 2 to the x. So the answer that you have for an exponential function looks very similar to the exponential function with base e. The rule is the function just repeats itself. So e to the x was e to the x, 2 to the x is 2 to the x. So that's kind of a neat thing. What's different is now we have this natural log of 2. So this natural log of 2 is the slope correction. Remember, it's only e to the x that actually has the y value equaling the slope. So what you have to do when you take a derivative when it's not base e is you put the stretch factor for the function into your derivative. So if you ever have any base, base e, base 10, base 2, base 3, the rule is the function repeats. So the function repeats is step number 1. And then what's the stretch factor? Natural log of the base. So if it's 10, it'd be natural log of 10. If this was e, you'd go natural log of e, and natural log of e is 1. So the stretch factor rule actually works when it's base e. So that's the rule. This is the last of the rules that you need to be able to kind of memorize or be able to work with. Now we just want to be able to apply them and basically differentiate and simplify. So we got an example, y equals 5 to the 3x. So again, reminder, your rule just has an extra layer to it. First layer is the function repeats. Whatever the function is, it repeats. Second layer is what's the stretch factor, right? So natural log of your base is the stretch factor. Third layer is what's the derivative of the exponent. So that's what we have to kind of follow. And again, we don't want to have to work harder than we have to. We don't want to take natural logarithms every time you have an exponential function. It works, but it's going to take you 4 steps instead of taking you 2 steps or 3 steps. All right, so y equals 5 to the 3x. Layer number 1, it repeats. So 5 to the 3x is 5 to the 3x. Layer number 2, what's the stretch factor? The natural log of 5. Layer number 3, what's the derivative of my exponent? Derivative of 3x is 3. And then really you're done. All we're going to do here is rearrange it. So you get 3 times the natural log of 5 times 5 to the 3x. We don't usually simplify this. We don't have to go natural log of 5 cubed or natural log of 125. 3 natural log of 5 is just fine as it is. All right, so that's kind of the basic example then when you're talking about a log function that is not base e and how you find its derivative. We're gonna do a couple more videos just to kind of chunk this lesson up. Anyways, that's There's some great Shrek stuff happening here, right? Lots of layers happening. Great stuff.